Hey everyone, welcome back to my video series on how to make a Pokemon catching game. In this video, like I promised, we're gonna have Psyduck run away from us. We're gonna implement some pathfinding AI. Let's get to it. So this is where we ended the last video with some Psyduck target practice, and I don't think we need those Psyducks at this point right now. So we're just gonna select all of them and delete them to clean out the level a little bit. Make sure you don't delete the trainer because we have hooked up a bunch of things to our controller here and I don't want to do that again. Or rather, don't delete them because you'll have to hook all of this up again. It might get a little tricky. But anyways, at the end of the video, this is where we were. We also had a lot of scripts, including one for a Pokemon controller, which we will be using for this video. If you don't know how to get to that, check out the previous video. Now, what we want to do today is two things. We want to make sure that our level is ready for some AI pathfinding. So we want Psyduck to be able to traverse the level on their own terms. And we want to implement that AI in a very rudimentary stage so that in the next video we can put a state machine in there and actually have Psyduck make some decisions. Now, how does it work to actually have an AI that will move non-playable characters for you in Unity? Well, you go to Window AI Navigation, and this is where you can make yourself a nav mesh. So we are going to assign a component to Psyduck at a later point. But what we will get is we'll go in here, and here we can have Unity calculate what the mesh will be, or rather what the level will look like from the perspective of a character with that kind of pathfinding AI on it. So let's say, hypothetically speaking, that we have a character that would be 2 meters tall with a radius of about half a meter that can do 45-degree slopes and that can step on a 0.4 meter or like 40 centimeter ledge easily. Well, we can have Unity calculate how accessible this level to a character like that would be by just clicking on Bake. So let's do that and see what happens. So you'll see down here that it says building a nav mesh, and that's what it's really called. It's a mesh that goes over your level, and all the blue areas a character that looks like this will be able to traverse. Now, as you can see here, there are some parts of my level, and obviously your level is going to be different, but some parts of my level are not very accessible at all. For instance, if a character with these proportions will want to go in here, there is no blue area at all. So if you want to send that character to this point, even though there's plenty of space here, it's never going to happen because there's no pathing there. Similarly, there are areas like big area here that we can't use and so forth. So the first part of this video, what I want to do is I want to make sure, do a little bit of level design and make the level a little bit less dense with trees and make it more accessible so that we're not going to have a super complicated game in terms of the pathfinding that we're going to be implementing. So we can clear this for now because we're not going to use it on this and go back to the inspector, navigation inspector, and we're going to clear this level out a little bit. So the first thing that I want to do with that is remove everything that should be something that an AI can just walk through. For instance, this bevel that we have here on our terrain, does that really need to be an object that is going to be a collision for our AI, or that our AI, it's not actually going to be a collision, but that our pathfinding is going to try to get around? I'd rather just have some clipping going on, honestly. The same for the little bushes, the little flowers, especially the grass. I want all of those things to just clip with my AI character for this simple game that we're making here. If you're making a commercial game, obviously you might feel differently about that, but then you're also gonna design your level a little bit more carefully than we will for this little exercise. So what we're gonna do here first is we're gonna go to our trees, and we added everything to trees just because I didn't want to spend too much time in that video adding other options in there, but we are going to delete a couple of things. So everything that's not a tree, we're just going to delete. So remove tree, and it'll immediately delete it from the map, okay? As for our trees, we want to create a little bit of an area for now that is not as densely populated with the trees. So what I'm going to do is I'm going to mess about with my brush size a little bit. I'm going to make it bigger, give it a lot of strength, like so. And I'm just going to start clicking and make the area where we're kind of in the middle of the level less dense. Now, since I didn't activate the overlay, I am holding down the control key, my left control key, to do this, right? So Another thing that I can do, I mean, I can clean it out a lot more than this, but let's start with that and then we'll see where we go from here. So anyways, remove some of your trees already to make it a little bit clearer to see, and you'll see that all those small objects that we made are now gone. Now looking back at where our trainer is at, this looks a lot less nice. There's no more grass, there's no more details, so we kind of want those back. So how can we get those back? Well, we can paint details just as we have painted trees in an earlier tutorial, and it works very similarly. So you can edit details and then you can decide, do you want to add a mesh or a texture? So a texture would just be a 2D texture that is put in the level, which is very rudimentary, won't look very great at a close distance, but for some purposes it's useful. What we're going to do is we're going to add a mesh though. So I'm going to click on Add Detail Mesh, and if you click for the object that you want, you'll find all the prefabs from the level in there, which is great. And let's say we want to use grass. So we click grass, but then it'll tell you, Unity will tell you that the LOD group, so the level of detail group, so those different detail levels that we discussed in the previous video, is not supported. So that's a problem. We can't add it for that reason. So we want to make a prefab that doesn't have LODs of the grass. So let's go to the grass and make that happen. So the prefab for the grass is under the plants in here, and we are going to make a copy of it. So I'm just going to no, I think I can just press Ctrl D for duplicate. There you go. And we get this duplicate. So I'm going to call this one just grass, I guess. Grass underscore no LOD. There we go. So then I'm going to drag this prefab. I'm going to drop it in custom. So we know this is the stuff that we customly made. If you want, you can add structure here, but it's not too many items that we're going to have in here. And we can double click it. And then you'll see that in the prefab, we do have those levels of detail, right? So what we can do is we can simply just go to LOD group, remove the component, and then delete these. There we go. And that should take care of the LOD. However, when we drag the grass into our map, we'll see nothing because there's nothing in there anymore. So we can just delete it. I actually could have just created a new prefab as an empty one, but whatever. So what we're going to do is we're going to make sure that we're using those materials to actually show something. So first off, we're going to create a mesh renderer. So a mesh renderer actually renders the mesh. So let's grab that. And then we are also going to set a mesh filter. Here we go. So the mesh filter is what you hook up to an actual mesh of something. So in this case, we're going to add grass, and I want the lowest LOD, but it's a little hard to see. So in this case, I think, or the highest. Let's do LOD 0. We can always, if we feel that this is too much detail and it's slowing our game down, we can go for a lower LOD, but I think this is fine. And then for the renderer, that's really where you hook up the materials, the lighting settings, and other stuff. So here we can just go with what material are we using. We are using the grass material. Oops, I misclicked. So I'm going to do this again. There we go. And that will make it look like grass. And then if we drag it in, we get a nice, neat little patch of grass. Wonderful. So I'm saving here for a quick second. And then I'm going to click on terrain again, edit details, add detail mesh. And now our game object can be the grass LOD. And that error will neatly go away. And we can just add it. And now we have grass in here. And similarly to what we used to have earlier with the trees, we can move across our map, click, and we'll get grass. It takes a second for it to render the first time, but so yeah, well, we can have neat amounts of grass on our map that will look good, and that we can traverse to in the same way like we used to, with the big difference that this will not get picked up by the AI pathfinding. So we don't have to worry about that because the AI will just run through it, which is great. So what I want you to do now, and I'm going to fast forward in a second, is look at the other prefabs that we have here, the flowers, the mushrooms, the rocks, the shrubs, the trees, the ones that we used to have, so the little pebble that we have, and do the same process and make your map look pretty again. And I'll forward now, and my result will look like this. There you go. So what I tried to do is I tried to create a bit of a valley, I guess, with the path is still there with some trees surrounding it, and I took away a lot of the trees. Now let's look at the terrain first, and then let's look at our nav mesh. So for our terrain, in the trees I have the shrub and I have the two trees that we originally had who are gonna block the AI's pathfinding. And then in the details I have shrooms, I have the poppies, some rocks, and some grass. Now one thing you'll notice, if the slopes get ridiculous, these won't look good anymore because they won't get placed well. So that's not something we're going to worry too much about, because we want our level to be somewhat flat, because it's going to be easier for the pathfinding as well that way. So talking about pathfinding, what I did is I put in 0.5 for my agent, which is twice as big as Psyduck, and a height of 1, which is also bigger than Psyduck, and a maximum slope of 30, while we'll actually give Psyduck the ability to walk on a slope of 45. So I'm making it a little bit more strict than what I'm actually going to do. And when I bake this, what I want to see is I want to see most of the level to be pretty playable. Now, as you can see, there's a good amount of space in the middle around the path that's blue, and that's really what we want here. There's also some stuff on the outside edges that you can't really traverse into as an AI agent for this game, but I'm going to put up some big colliders anyway so that the player can't get there, and we'll make this unwalkable in a little bit. Now, before we get there, as you're designing your level, one thing I want you to do for gameplay purposes is we are going to restrict our motion for Psyduck to the inside of the path somewhat. So Psyduck is going to walk around and he's going to go to random locations as we try to hunt them. And we're going to use 4 simple coordinates to define the areas in which Psyduck is comfortable walking. And we're also going to use those edges for Psyduck to flee to when they get in trouble with the player. So we need some coordinates for that. And to do that, what I did is I put 4 Psyducks out on 4 points in the map. So the first Psyduck here is down here, and we don't need to worry about the Y value because that's not relevant, but the X and the Z, this is a 2-dimensional space for a second, we do. So we have 0 on the X and 40 on the Z. Then my next Psyduck keeps the same Z value, but now it's 140 on the X and is down here. Then there's a Psyduck up there with 140 on the X and minus 60 on the Z, and if you see the pattern, you'll probably figure it out. The last one has 0 on the X and minus 60 on the Z. So it's basically a square that we are drawing up here in which we are going to have Psyduck wander around and play the game. Now, an important thing here is if we are looking back at the nav mesh, all these Psyducks need to be in areas that they can easily reach, because we're going to also use them for flee points from the player. So if I double click on my Psyduck here, I want him to be in a nicely, in a very blue space with a lot of entry paths to it. So Psyduck, we don't want the Pathfinder to have to calculate a lot to get there. So this is looking pretty decent. And I mean, it'll look decent for all of them because obviously I designed around this. But as you can see here, there's an entry point this way, an entry point that way for this Psyduck. Psyduck up here, again, entirely in blue. So what we don't want is a Psyduck that's going to be somewhat blocked off and that's not easily going to be able to find the spot where they might flee to. So anyways, with that in mind, I feel I'm happy with my terrain here. I'm also happy with what it looks like aesthetically. If I press play, you'll see that, you have some weird hills around it, but as we're walking through it, we got some grass and we got some nice poppies left and right. And usually what I like to do is just around the path, clear out all the grass and everything, and then put some points that look kind of nice. Like there's a lot of poppies here. There's going to be a spot where there's going to be a lot of mushrooms. There's a lot of rocks up here just to break the monotony. And similarly in the distance here, we can see a forest on a mountain, while if we look the other direction, we see a mountain that's just grass really. So that's kind of what I did with the level to make things look all right. Try to have variety in there, try to put stuff randomly, and that will look nicely. All right, so I think we're ready to move on here. Just one thing, if you're struggling with getting Psyduck access, usually it's going to be trees in the way or the slope. You already know how to remove the trees and the slope, the trees and any other kind of objects like that. The slope, in case you don't remember how that worked, it's this button here, and you can use the effects to flatten out the slope. Well, there's some stuff going wrong here. I guess I didn't press the play button. Accessible. All right, let's get to the next step now and implement those invisible walls. So how are we going to implement those? Well, what we can do is we can pretty much just create an empty object. So let's create an empty object, and it's game object, and I'm just going to call it Collider. And I'm going to add a Collider component to it. So let's just use the Mesh Collider for it. There we go. Sorry, we don't have a mesh, so it should just be a regular box collider. Let's do that. And I'm going to make this collider pretty big. Let's give it a size of maybe 50, 50, 50. And as you can see here on screen, that collider is becoming somewhat visible. So yeah, it could be, it's right here. It could be a lot bigger actually. So I think on our Z-axis we could go with 300. Well, it depends on how big your level is, obviously. But yeah, that's what it looks like for my level. So let's get back to the collider and double click it. And then grab this so we get the gizmo. And then we can move it about a bit. And I want to put it like it. Now for this part, you probably want to set your camera speed to something high because we're far, we're zoomed out quite a bit. So I'm going to just put it here. Now, if you want to have an easy view that doesn't use perspective, you can click on top to go into ISO. And isometric orientation will flatten everything out because there's no real perspective anymore. And you can easily then just start scaling this to your heart's desire so that it really fits your map well. You just want to make sure, the player can still go where they want to go. And you can just copy the collider as needed, move it to the other spot as well. I'm going to put this guy a little bit further out. Only half the X value should be fine. And then copy it again. And bring this guy out. And for this one, we want to change up the value. So let's do this one at 250 and that one at 50. And then we can go up here. Yep. And then the final collider down here. And that should all still be fine. You want to just make sure that when you click on your Pokemon, yeah, unfortunately it doesn't select everything, but if you click on the Pokemon here and then make sure, that's just for me, but I don't want my collider to interfere with that too much. But anyways, that sets up colliders. Now, there are a couple of ways to make so that the AI is not going to walk into it. So if you have an object that uses a mesh renderer, you can go to the fourth option in navigation to add it here and make sure that it doesn't get included in the bake. However, our colliders don't have mesh renderers attached to them because there is no mesh to be rendered here. So an alternative thing that we can do pretty easily, even though it's not the most optimal thing right now, is to just add a nav mesh obstacle, which is actually dynamic and you can use it for moving obstacles. Well, that's what you would usually use it for. But just to make things pretty easy, we're going to use it here. And we're going to have to copy those numbers from our box collider orb as well. So the nav mesh obstacle is going to keep our Psyduck out of that area, while the collider itself is going to keep our player character out of that area as well. Well, actually, the collider itself will, I think it will keep Psyduck out as well, but then we are still calculating paths that might go into that area, which is not something that we want. So yeah, so if we look at the nav mesh obstacles, we should have those set up for our 4 colliders as well. There we go. And what we can do here to keep things a little bit cleaner is just create an empty object, call it colliders, grab those 4 colliders, drag it in there, then we close this. There. So all we need to do now is make sure that everything is working properly. So, oops, I'm going to just double click my trainer because we have so much culling. Turn off the ISO by clicking on here, that isometric view if you were in there. And that should allow you to get, and then give it a click up here, and then you should be free to move your camera around again as you like. Although you want to set it so that it's at perspective because that's the usual view that we are looking at. If it's locked for some reason, there's a little lock icon that you can click here. Anyways, double click my trainer again. So we're here and let's see where the nearest collider would be. Like, yeah, somewhere down there. So let's try to get up the hill and make sure that everything is working here. So here we go. Let's run up the hill. And oh, look, it's a Psyduck. So at some point we should bang into an invisible wall, which is what we want. Yeah, and we might get that animation. And here we are at the invisible wall. So it's not a great spot, but it keeps us in the map. And, if you've played Skyrim, I'm sure you've seen this kind of stuff happen a lot. Sometimes with slopes, if the raycast can't detect the ground anymore, we get into a little bit of an issue. We can fix that by extending the length of our raycast, but that's not something I'm going to worry about right now. right now we are going to bake our nav mesh first and move on with this video. So we've already baked the nav mesh quite a few times now, but there's still stuff that you're not aware of yet. So what we're going to do is we're going to go to bake. For our agents, there's a humanoid agent and the default settings. So we're going to put 0.25 in because that's what our Psyduck kind of has as a radius. I know this because I already tried this out. So this is just something that you experiment with. And then the height of Psyduck was 0.8. So that's what we'll do. For a step height, 0.75 is quite a lot. I'm going to put that at 0.4 and we'll give 45 for the max slope. I think that should be absolutely fine. Actually, we can probably get away with making this smaller. So then we're going to copy these things over in our bake area. So radius 0.25. Next up, we've got all these tips are so helpful, but they also do get quite in the way. Slope and 0.5. Let's make it 0.2. Or actually, let's keep it at 0.4 because I don't want to have to check the nav mesh again. So we'll set this at 0.4 as well. Maximum slope at 45. So we got them at 30 here. So yeah, let's make it so that 45 even works as well. Drop height, jump distance. Lovely, lovely, lovely. And then the height mesh, that's actually important. So if you're only seeing advanced here, open it up. Make sure you select height mesh. If you do not have a height mesh, the AI agent is going to hover over the terrain a lot of the times. So you want to have a height mesh calculated as well. So the nav mesh will determine where your character can go and where it can't go. The height mesh will calculate how far from the mesh underneath the character is and adjust accordingly. So once we have the settings set up like this, we can bake and hopefully we don't run into any errors now. So building nav mesh. It's taking a couple of seconds, but I'm gonna let it complete so you see how long it took for mine. If you have a less good computer, this could take longer. If this is taking forever, remove trees, make it less intense, remove details. You know, I have a very good graphics card in here. I'm not seeing any frame rate issues, but just in case. And with that, we have a nav mesh. Now, let's put that nav mesh a little bit to use. And to do that, I'm going to delete my Psyducks down here. All right. Make sure don't delete anything you still need. Get my inspector. Okay, I want to set my camera. If you're struggling with that, make sure you set your camera back to something that makes it a little bit smoother to move. There we go. And then go into your prefabs, bring out a Psyduck buddy. There you go. And then we get a Psyduck. And yeah, let's add some code to our Psyduck so that we can move them around. So there's already a Pokemon controller on there and a capsule collider. That's all we really are going to need. So let's go to our code now and have a look. Or actually, I'm being too hasty here. I forgot to add my nav mesh agent. So a nav mesh agent component, you'll recognize the humanoid thing. It will bring in a character for us to work with the nav mesh. Now, speed we're going to leave at 3.5 for now. And you can mess with these settings. You can use it. You can look at the Unity manual if you like to see what it does and what it doesn't do. The radius 0.25, and as you look at Psyduck, you can see why I would use that radius. And the height is 0.8, which we remember from previous adventures with Psyduck potentially. What you can also do is offset the base if for some reason you'll see issues in the animation. If you put it at 0.5 is a lot, but you can move the base around. I think for now this looks good. And so now our Psyduck has pathfinding with this nav mesh assigned to him. So that's pretty cool. So let's write a little bit of code to actually put this to good use. So I'm going to grab that nav mesh really. Oops. Component, grab this one. So nav mesh agent. And I'm writing this in start because you don't have to, you can just say it from the start and then it doesn't have to update every frame because if you're going to move about with it, you don't want to set it all the time. And we're going to set the destination. So as you can see, there's lots of options here, but destination is one of them. We're going to set the destination to, what am I doing again? Oh yeah, I need the trainer. So let's grab the trainer first. So game object dot find trainer, just using the name, and we're gonna create a, actually, yeah, it's a game object, I think. Game object trainer is equal to game object. That's how I should have done it straight. Right, here we go. So, and we want to send Psyduck to the position of the player, basically, from the start. And this will just trigger right away. So let's see what that looks like. Here we go. Whoops. All right. And we're going to press play. And if everything goes well, Psyduck should be walking right up to us. There we go. And as you can see, he's still, I don't know why the rotating thing, but he got to the destination where we were, and when they reach the destination, they just have a little jiggle going on, I guess. You can probably fix that with some settings. But as you can see, as soon as that destination is set, it just needs to be set in one frame, and then every update, it'll still keep going. So that's neat. So yeah, that's how you can make Psyduck walk up to the player. So what would you do to make Psyduck flee away from the player? Well, that can be done pretty similarly. So let's grab transform position of Psyduck, because we're in the Psyduck right now. So we're going to grab the position of Psyduck, and then we are going to add to that transform dot forward times 10. So the destination of Psyduck is going to shoot Psyduck forward up to 10 meters away. So we're starting where Psyduck is, and then we use a forward vector of him to know where Psyduck is angled at, 10 feet away. So how does that make him run away from the player, you might ask, Bob? Well, we're going to make Psyduck rotate away from the player. So let's do some Quaternion stuff. So transform rotation equals to Quaternion dot look rotation. And similar like we've done in the past, we're going to calculate the rotation to look at a position by subtracting. So trainer, let's see here, trainer transform dot position. So subtracting the two positional vectors will give us the vector that has the angle between both of them, and we're going to rotate towards that, and then we're going to tell Psyduck, hey, start running forward. So if we put both of those together, let's see what that does for us. Oh, look at rotation. I don't know if that's like going to switch him up entirely, or if there's a delay, or if it's like a stepwise type of thing, but let's find out. So let's press play here. All right, where's Psyduck? And Psyduck's running away from us. Psyduck, no, well, just for 10 units, obviously, and then Psyduck finds a location. Just for the sake of fun, because this is the end of the video, let's do this. Let's have Psyduck go 100 away, which is a lot of distance. And let's put the speed to 10 to really make Psyduck run. 100 is actually a lot of distance. Let's maybe go like 50, because we're gonna... it might just shut it down entirely, because there's no path to 100 away probably. So we'll see what happens when we do this. Let's try to see if Psyduck can still do it, because it might be too far away for Psyduck to do anything. So yeah, that's kind of why you want to work with a lower number, and why you need to know that there is a path to where you're sending Psyduck. So that's one of the things I wanted to illustrate here as well. If there's no path, well, Psyduck is just going to stand still. So let's try maybe 20. That might still be within bound, or let's just do 15, because I want to end the video now. So let's do 15 and see if Psyduck can still make it. But that gives you some idea of how the nav mesh works. So he's going to try to find a spot that's 15 away, rotating away from us. There you go. So that makes him go a little bit faster. So you got to be careful not to send them off on a wild goose chase where there literally is nothing there. So anyways, that's the basic of setting up your nav mesh and your pathfinding. So I think that's a really neat point to end the video here. And in our next video, we're going to take things a little bit different. We're going to add a finite state machine to it, so that Psyduck, depending on our behavior, will have different behaviors. If we do something Psyduck doesn't like, we want Psyduck to run away. If we are not interfering with Psyduck in any way, we want Psyduck to go to interesting places on the map. So that's going to be the next video. Thanks so much for watching. I'll see you there. Bye.